Hi, good day. How are you guys? So tonight I'd like to present the topic which I presented last year about functional effects in Ruby, which in a nutshell is like how do we apply the functional concept in Ruby, especially in our day-to-day life. So just to quickly recap about my talk last year is that I discussed quickly about why functional programming. And no offense to Husker, this is just a joke, which I found on Google. But to me, I look at what I do day to day, and most of the things we do day to day is actually building things that handle requests, handle requests, fetch data from database, and do some computation, return response. It's mostly a request response lifecycle. It's not that rocket science, but once in a while, I will come across a code that's written in a way that, you have a service object that will rescue an exception and then raising exceptions, and then the upper layer object will rescue those exceptions, maybe log the error, and then raise another exceptions. And then your controller needs to rescue the exceptions to render the error messages. To me, it looks like this, and my brain is small, I'm not that smart enough, and to me, it's really hard to reason about the code. And when I see this kind of code, I kind of flip the table because this is so hard to understand what's going on. And in the last presentation, I went through about, that Ruby can do functional programming. We went through some of the attributes that, in Ruby, you can do functions with Lambda or prop or block, for example, as shown in the code snippet in here. And in Ruby, you can also do high order functions. And what it means is that you have a function that takes either input or a function as an input, and then your output will return either data or another functions, as shown as in this code snippet here. And also, Ruby can do carrying as well, or partial application. What it means is if a function takes two arguments, you can partially apply the first one, like in this example snippet here, like adder x and y. I can make adder 1 by partially apply the first input 1, and then I can then use this as a function to apply later on an array of numbers, for example. And also Ruby can do function composition. Well, here it requires a monkey patch because we haven't come to consensus on which syntax, but if you patch it yourself, you can actually build your own kind of operator to compose multiple functions together. I might be going this a bit too fast, but if you want to know more about this, you can check out my talk last year. But last year when I gave the talk, I have a cliffhanger where I talk about what about error and exception handling, which is the main reason of my frustration here. But then to handle error really good, and this is where I actually doing a journey into functional programming language. I learned a thing called monads, and that's a library called DryMonads, and the way it describes monads provide an elegant way of handling errors, exceptions, and chaining functions so that the code is much more understandable and has all the error handling without all the if and else. Sounds pretty good. But one thing is that I highly against people do is Google what the hell is monad, because even in the DryMonads documentation, it says monad is a monoid in the category of endophantus. I don't know what that is. But in this talk, I'll try to present my own understanding of monad, which is it's something that's actually not that hard once you understand, but it's just difficult to explain. So for me, the way how I like to visualize monad is I like to think of it like pizza boxes over there. So DryMonads give you one type of monad called maybe monad. So imagine you order pizza and they give you pizza in a box, but you don't know is it really that's pizza or not, right? So you have a maybe monad, and then the maybe monad inside actually can be none, or maybe there's some pizza. And in DryMonads, they give you a few operators that you can use to operate on the box, because inside there is a pizza, but you don't know it's there or not. But you can actually do something to the box. So the first one that DryMonads give you is a thing called bind. So a bind works this way. Imagine I have a pizza in a box, maybe there's pizza inside, I don't know. And then I use a bind with a function to slice a pizza. And what bind does is bind will open the box and check whether there's a pizza or not. If there's no pizza, I can't do any function on it, so I'm just going to return none. But if there's some pizza, I'm going to apply the function slice pizza, and I get a sliced pizza. And then there's another thing called fmap. Fmap is very similar to bind, as you can see here. The difference is that in fmap, after it's sliced pizza, it returns you the sliced pizza inside a box. That's why in here, it returns sliced pizza inside a box called sum. And also, there's another operator you can use to operate with the box. It's called OR. So if I have a box of pizza and I open it and there's nothing, I'm going to be flipping the table, for example, in here. So enough of this is the theory concept, but let's see in action in here. So, for example, in here, I have pizza in a box. And make it bigger? All right. Is this good enough? A bit more? Cool, thank you. So if I run this, all right, if I know how to run this thing. Oh, sorry. If I run this thing, if you see like with dry, sorry, I haven't properly introduced dry monads. So here I require dry monads, and this is just some boilerplate to set up the dry monad. I put it under constant M. So if I call dry monads maybe, and with pizza in a box, and I get some pizza because there's pizza inside the box. But, and furthermore, if I call some pizza and some pizza, I get, like there's the thing inside the box, and therefore some pizza. But if I call none, is just a none, like it's pretty straightforward, like the picture earlier. And also with same thing, if we call the operator like, bind, fmap, and OR. For example, I have a function here, slice pizza, where given a pizza, I'm just going to return pizza slices. And I've set up a few scenarios where, I'll try to slice a pizza, and what happens if I put nothing inside the box and try to slice it? What do we get? And also, I'll try to use fmap as well, and also, if I don't get my pizza, I'll be angry and I'm going to be flipping the table. And let's see what we get. Yep. And it works exactly just like how we illustrated. If you look at this concept, it's actually not that complicated. Like it kind of makes sense. And also and you can chain this even longer. For example, if I order pizza, the guy make the pizza, put it in a box, and then he's going to ask someone else to slice it and deliver the pizza. And we got pizza delivered. And there's also another pretty interesting operator, which is actually not properly documented in the documentation, but it's actually you can use it. It's called a T operator. So a T operator is that it's an operator you can use on a box with a function. And what it does is, for example, in this case, I have pizza in a box. When I open it, I see there's a pizza, and I want to call John. The action of calling John has nothing to do with pizza, right? I call John and say, hey, John, your pizza is here. But I don't care what the result of calling John is. And what T is useful is to pass the original input I have when I call John. So what it does is I'm passing the pizza to the function slice pizza, and which then I get back the some slice pizza. So that's what T is. It's mainly used on the things where the result of the functions like you don't really care about, and you just want to pass the original input in. And let's have a look. So for example, you order pizza, they try to find parking, and it can find parking. And also another case where it couldn't find parking, and we'll see what happened. And there you are. So for example, find parking is a function that returns true, and it's just going to ignore the result of that function. It's just going to pass in the original input. And when there's none, it's just going to treat it as a none and just meh. And next, is another type of monads that dry monads return is called result monad. So in example here, it's like, I'm cooking pizza, and cooking pizza has two results, failure or success. If failure, I get failure, burnt pizza. If I success, I get my success pizza. And let's see that in action. So over here, I have two cases. First one is like, like my pizza, I didn't get my pizza. There's something wrong in this chain of functions together, but I don't know what happened. I want to know why. Another case when it works. As you can see, the first one, okay, when it failed, I can see why. So when I chain together, and normally you use this when you want to pass an extra information when things doesn't go well. And here I can see, okay, I didn't get my pizza because driver cannot find parking, and when the pizza is successfully delivered, I'll get my pizza. And then there's another type of monad which is called tri-monads, and tri-monads is just a wrapper that works like a rescue block. And what it does is you use tri-monads normally for operation that may result in an exception. For example, if I'm ordering pizza online, I didn't pay my internet bill, and I got internet network is down, or maybe I got like the server issue error 500. Or if I order successfully, I'll just get my pizza wrapped in another monad, which is called value monad in here. And let's see how this one works as well. So in here, I have two scenarios as well, when one is successful and one maybe there's failure. For example, in here, when I tried, the delivery guy, got here, find parking, but couldn't get in. The security didn't let him, and he tried to call the railroad staff to open the door, but, Vodafone network is down. And let's see what happened when this thing happened. And when success, as expected, we got our pizza delivered, but when it failed, you can see that we actually get the error wrapped inside an error monad that tell us, okay, sorry, Vodafone network is currently down. So, this example is pretty simple, and it's like, okay, but it seems pretty trivial. But how do I use this, in a day-to-day life? Example in here that I've recently encountered is that I recently have to work on come across a code where anyone here knows AWS SQS? For those who doesn't know, it's just a queue system. So you put a message inside the queue, and then you can take the queue out from the pool of messages. So here is a worker job where it listens to the SQS queue, and then inside has a message body. All it tries to do is find order by code ID and then purchase the order. It's very simple, right? If the job successful, delete the SQS message, otherwise do nothing, log error. But then if the order has already been purchased, I want to delete the SQS message and log error warning. Typical, Ruby code I've seen, for example, is, you have my code ID, I'm gonna, fetch my order. If my order is there, great, I'm gonna delete it. Otherwise, if I have error resource not found, I'm gonna raise errors in here. And then I'm gonna rescue, and then I'm gonna do a bunch of stuff. But the fact here, I'm raising exception and then rescuing, this code looks pretty tricky. If I show you this code, you won't get it in 5 seconds. You're like, what? Wait, give me time to sit down and digest this code. But using dry monads, I'll give you a picture how it could have been written that is much more readable and understandable. For example, in here, it's similar. I got my code ID retrieved from the message body, and then what I've got in here, I've got a function called or method here called get order by code ID, and then I bind it. And in here, I'm chaining the function together where all the encapsulation of error handling has been well contained. And then in here, after I bind it, and then I just purchase order. If my purchase order success, I delete the message. Otherwise, I'll log error. And all of those rescuing and error handling is not all over the place. They're all now well contained in here. Like it seems to be a bit more code, but the end result is that it makes the code way much more readable and easy to reason. And like this thing that I'm talking about is not something that I came up with. Apparently, like this is actually a common problem that has a lot of smarter people has been trying to solve as well, and they are also frustrated as well. And this thing is actually called railway-oriented programming. And in railway-oriented programming, the main issue is that, you know, like in typical imperative code, any part of your code can return early by raising exception stack, and it's very hard to reason. In railway-oriented programming, you try to treat that, you know, your program will always have two tracks, success or error. Pretty simple, right? And the way to make this happen in each of these components inside here to be self-contained and has an interface. The interface here is that, for example, you know, I have an input and then my output, I either have a success and a failure. And when I fail, then I'll just go through the red path, which is not gonna, like, you know, it's not gonna go continue the green path anymore. And if you chain these two functions together, validate update database, you can see that it just, you know, if it's successful, it's just gonna continue down the green line. But if any of these fail, it's just gonna go down the red line. And if you chain more, it looks like this. And if you chain more and more and more, I'm not sure if, you know, when I was kid, I remember I was playing, like, building these Thomas, like, train tracks. And yeah, this is why it feels like, you know, it's like rather messy things. You have now, like, you know, a train tracks that is easy to reason, like, okay, where's the train going? And it makes, like, you know, reasoning with the code much easier because your flow is much more organized. And to give example in here, like, you know, for example, here, I'm doing the same thing. I have a pull request where I'm trying to validate, get user, update database, send email, and return message. Here I've constructed a user object that, you know, do the typical stuff, but instead of Rails, I just like kind of like make a similar interface. And I have a job that send email because that's part of what we try to do the request here. And here I've set up a list of functions. So as you can see here now, I have a valid function that, you know, if you look at this picture in here, I have an input and I either go on success or failure path. It's similar in here. Get user, technically I know that, you know, get user will gonna give me always the green path, therefore I'm just gonna always be on the green path. Update database, you know, like this is an operation where I don't care about the result because I'm doing a side effect to a third party, to external system. And send email, this is something that may have exception due to network issue. So I'm gonna wrap in a try things. And then I can compose all of them together with function. I mean, if you want, you can just use a normal Ruby method, but in here I just made flexible. Then I can chain it together. And my input wrap in a pizza box, and then I just chain together with a bind, you know, with function to validate, get user, update database, and send email. If any of these all successful, I'm gonna get a monad that, you know, when I ask if it's successful, it's gonna be a true, and I'm gonna get my return successful message. Otherwise, I get my failure message. And here I've already pre-set up some of the cases. And when I run it, it works. And you can see that I got my user successful. When I fail my validation, this is what happened. And the same as when I have a network error and I try to call it and I got like exactly what happened. But, you know, to some people looking at this code, they'll be like, you know, I'm not used to seeing this, using this kind of code. Like if I use this in my code base, my colleague will raise an eyebrow like, what are you smoking? Like, why are you writing this kind of code? Like, I don't even understand what is M right, M maybe, like what we're talking about, right? Like you want to introduce this code to your code base, but you want to do it in a nicer interface that is more like, you know, Ruby friendly way. And this is where the creator of Dry monads have come up with is called DryTransaction. What it is a business transaction DSL that provides a simple way to define a complex business transactions that help us to process many different functions altogether. Maybe it's easier for me to show you than reading what it means. So So over here, I have exactly the same thing in here, but instead of refactor using DryTransaction. And if you look in here, now what I have is I have an object called update user transaction that I've included the module so I can use the DryTransaction. And then I've defined a bunch of steps, and this is my transaction step, and they're all chained together. So when I call this object with an input, it will run through this step. It will step in, do a validate, get user, update database. It's the same thing as what we've seen earlier in here. It's just that this one might be nicer compared to this. And also this one, I've defined it in here, which is inside a Ruby method instead of functions that may be a bit awkward to use. In here, I've defined like the same thing, my validate, my get user, and update DB. And what's even nicer in here is that DryTransaction provides you with a pattern matching on the result. For example, let me close this one so you can have. So in here, I call the update user transaction, and I can pattern match on the cases. If it's success, I want to put success message. If it fail on particular step, for example, if it fail on when it's trying to send email in here, I may want to log the message error, and I want to give a different error message. Otherwise, I have a blanket rule to, if anything else, I'm just going to give this error. And here I've already set up the example here, and if I run it, you can see when it's successful, you're going to get success, user updated successfully. Failed validation, you're going to get exactly what it has been pattern matched against. And when you fail, when you fail the network error trying to send email, you're going to get exactly the same message in here. And for me, this kind of code, when I look at it compared to initially when you try to, seeing this code compared to seeing a code where it can raise exception or rescue exception somewhere else, to me, this is actually made the code much more reasonable. Yes, while it may introduce a bit of complexity, but I find that this complexity worth it because it's so easy for developer to write a code that raises exception, while this type of code, it makes you to be conscious about a decision to raise exceptions. And to me, when I see this kind of code, this is how I feel when I do a code review. And that's it. Thank you.
Immutability.
Yes, I didn't cover that because in Ruby it's hard to do immutability. But to me, even without immutability, if I can just do exception handling really well, you will gain a lot on your day-to-day Ruby code.
I think there are some libraries that do immutability.
Yes, there are libraries like.
I've only toyed with them, so I know. But that was great talk. Thank you.
Thanks. Yeah, so there are libraries like Hamster that can do that, but they can't do those like deep copy nesting of hash, so you can't achieve those pure immutability like other functional languages.
Cool. Thanks, Jaya.
Thank you.